Okay, let's get started. In this video, I'm going to talk about how my thinking has evolved and how that will impact how I image going forward now that I've decided and have a date to put my two telescopes into Starfront Observatories in Rockwood, Texas. A little bit of context: about a year ago, this vision came to me that I should really be preparing for the day when I put both my scopes into a remote observatory. And that day has come, December 29th. I'm dropping off my two scopes at Starfront. And as a result, now I can look at imaging a little bit different than I have before, or how I approach it. I have been a traveler. I can't image from my backyard, so I've been hopping in my camper van and going to a dark site, sometimes up in the Sierras, sometimes down in the Southern California desert. And at most, I get 3, 4, 5 days to image. But now, with both my telescopes in a remote observatory, I'll have more days available to image, weather permitting. So that gives me an opportunity to change things up, and that's what I'm going to talk about in this video. And I'm also going to touch upon the Moon-Avoidance feature that's available in Target Scheduler. So this is how I used to manage my imaging. I had a spreadsheet, bunch of information, project candidates, and then when I'd image, I'd try and document, how many exposures did I take and all that. It was a bit cumbersome, and that all goes away now that I'm able to use Target Scheduler. And I've been using Target Scheduler for the last few months, and I've gotten familiar with it. And how I set up my projects in the target management area was different than how I'm going to set it up now. Now I'm going to do a finer level of exposure plans and everything than I had done before. And the other thing that's happened, based upon my 4 years of imaging experience, consistently the oxygen 3 filter has been the most sensitive to moonlight, and has also been the noisiest data that I've collected. So I have an opportunity to improve upon that. And the way I'm going to do that is with Target Scheduler. I'll have the ability that Target Scheduler will only image with the oxygen 3 filter when the moon is not up. And I'm show you where that settings can be set, and a little bit of background on what the moon avoidance feature looks like in Target Scheduler. So let's just kind of start here. Target Scheduler in the target management area has projects that you can build and profiles. And let's just take a quick look. And again, you can have more than one profile. For this device, my mini computer, I am only attaching one telescope to it, so I just have the profile for my EdgeHD 8 setup. So let's take first a look at the exposure plans. I'm working with 9 exposure plans. What I found with the EdgeHD 8, it's best if I keep my exposures to the shorter duration rather than the longer duration, because trying to reduce guiding errors and those type of things. Again, the telescope's going to be on a pier. It's going to be collimated, but I have found in the past that the longer my exposures, the higher the risk for elongated stars. So really, I don't mind taking shorter exposures that swamp the read noise, but then reduce the risk of having elongated stars. And as a traveler, I was moving that EdgeHD 8 around all the time, and I tried to get my collimations spot on and those type of things, but it was a challenge being a traveler with the EdgeHD 8. Now that it's going to be in place, it's going to get collimated, and I think I got my back focus right where it's supposed to be. But still, I'm going to be conservative, and for my narrow band, I'm only going to do 3 minutes or 180 seconds, and for my RGB targets, I'm only going to do 120 seconds per exposure, but again, I'm going to take a lot of them. And then for my RGB stars, they're going to be 60-second exposures, but I'm only going to take 15 exposures per filter, and we'll go into that. So as we see here, I already have my first target set up. Because I'm using this different project hierarchy, I'm rebuilding everything into this plugin for the EdgeHD 8. And you'll also notice here that I have HASI, stars, and then a separate for O3. Again, I only want to image going forward O3 when the moon is not up. Again, I'm trying to improve the quality of the signal that I get with the O3 filter, and therefore I've decided I don't want moonlight affecting it at all, because the frequency of this filter, I think 500 in that range, is more of a challenge than the HA and the S2 is when it comes to impact of moon light. So this is what we have here, and so let's set up a target real quick. It starts by going into the Sky Atlas, NGC 1952 Crab Nebula. I've found it in the catalog in the Sky Atlas. Going to set it for the framing wizard. Here it is in the framing wizard. We'll let this complete. Here's the coordinates and everything. So I have that set there. I go back to the plugin. I'll start with the HAS2 targets and add it. So I go here. I want to add a target. Now, at this level, what I am saying is the state of the projects, the targets underneath here will be active. A normal priority, I can change priority. I can make items listed under this high, low, or normal. I'm saying normal. The target has to be available for a minimum of 30 minutes to be considered for imaging. I want it to minimum altitude of 30. I can change that, so I have flexibility there. I could even work with a meridian window, like 2 hours on either side of the meridian. So there's a lot of parameters you can set here. I'll go into that maybe in another time. And so that's what we have here, but let's add this. And oh, wrong level. Let's go. Yeah, no. Here we go. I want a new target, so we have to edit. I'm going to import coordinates, and I have an option of doing it from the framing assistant, a sequence target, or a planetarium software like Stellarium. I'm going to use the framing. There it brings in the coordinates. As we can see here, those are the coordinates: 22,052, 22,052. Okay, there's going to be no rotation. Region of interest is 100%. Have that there. Now I am going to give it a name though, because this is _ HA. This naming convention is totally arbitrary, but that's what I'm using. And then I'm going to associate a exposure plan, and what I'm going to want is the HA. So I go down here, HA. I'm going to want 100. 103-minute exposures, and then I'm going to want the S2. Good, and then I'm going to save it. All right. So now let's add the O3. And we're going to go ahead and edit. We're going to import. And, oh yeah, we're going to import from the framing assistant. You notice that these are the same coordinates as I imported here. And then we're going to give this the name of underscore O123. We're going to associate an exposure plan. And again, we want the oxygen 3.1, which is the narrowband O. And we want 100. And we're going to save. Okay, so there's one more thing we can set here. I'm going to go in here and I'm going to take 2 of the O3 and I'm going to dither. I'm going to save that. And then for the HAS2 here, I'm going to go in and I'm going to take 2 of the HA, 2 of the S2, and then I'm going to dither. Now, and we got that saved. Now, I'm exploring here, and I may cut this down to 1 exposure and then dither. Again, my understanding is how often you dither can impact the quality of the resulting signal that you get. So if I'm really going for quality, it might make sense to do 1 exposure, dither, 1 exposure, dither. But I'm in exploration mode here, so I may change my mind once I start to collect data where the data is collected when there's no moon. And then maybe I can come in and make an adjustment if I want at that point in time. All right, so I've added another target. Oh, let's add my stars. So let's go into here. Let's add a project. Let's import. Framing wizard. Okay, we got a coordinates, and this will be called underscore stars. Again, this is all arbitrary. How you structure your hierarchy and everything is up to you, but I'm trying to accomplish something here that I'll show you in a minute. I don't want O3 captured unless the moon is down. So, okay, we're going to do that there, and then we're just going to add our plans. And red is good. We're going to want 15. Green. 15. And let's get a blue filter. Okay, let's save that. All right, so that all looks good. So now I've taken an object, the Crab Nebula. I've split it within my project hierarchy so that I can accomplish certain things when it comes to the moon, the impact of the moon. Again, I am not, I'm willing to image when the moon is up, but when the moon is up, when it comes to HA and S2, I want my target X number of degrees away from the moon. And as the moon rises or gets more illuminated, working from new moon to full moon, I want that distance in degrees to increase as the moon becomes more full. And so I'll show you how we do that. Really straightforward. We come down here to our plans, and let's start with narrowband because it'll be the easiest to understand, I think. And if we look here, there's a feature called Moon-Avoidance. And so for my O3, I've set Moon-Avoidance to true with a classic separation of 0, classic width of 1. But the key thing here is moon must be down is true. Okay, so if the moon is up, target scheduler is not going to consider the O3 for a candidate to image. So the moon must be down before it considers this exposure plan. So now let's go to, we'll just go HA, or to, yeah, HA. Here, when it comes down to moon must be down, I have false because I want to image. I'm willing to image when the moon is up, but I'm setting some requirements here. These parameters are establishing a requirement of how far that moon or my target has to be from the moon based upon the illumination of the moon. And so I have 90 and 14 here, but we're going to go to this document first. And so this is part of Tom Palmer's target scheduler documentation, and he gives attribution to where they've pulled this from, so you can read that if you look at the documentation. But definitely for a distance of 120 and a width of 14, so I have 90 and 14. What we see here is a representation of 0 is the new moon, and about 15 is the moon being full. And so let's just take a quick look over here onto this monitor, and we'll go to the moon phases. So again, here's, just for representation, here's the new moon. And here's the full moon on the 15th, and then illumination starts to wane into the next new moon. So what we're saying with these moon avoidance parameters, as I've got them set here, is I'm giving requirements to target scheduler that will enable it to understand when I'm comfortable having this exposure plan activated and imaging based upon where the moon is. So, you know, again, new moon, full moon, and new moon. So let's look at this in a different way, and let's look at these parameters here in maybe a different representation. So what we want to look at here is a representation of what we're trying to accomplish. This chart graph is using a distance of 120 and 14. Again, I'm using 90 and 14. I think if I used 120 and 14, it would be really conservative. But I'm going with 90 and 14. But essentially what this is saying is when the moon starts to new moon, it will image. Okay, the moon is not up. I don't care about the target being some distance away from the moon because the moon does not exist during the hours that I'm going to image. But as it becomes more visible during the hours that I'm imaging, and as each day of illumination increases, working towards the full moon, that up here, this is a representation of when the full moon would be, I want to increase the distance that my target is from the moon before it is considered, has to be this distance or greater away from the moon before this exposure plan should be used. And again, here's 15, roughly the full moon, and again, either side, new moon to new moon. So let's look at this a little bit differently, and we can use this chart here. So again, here's the default 120, or not the default, but this is what was on the chart that we just looked at. And so what we see here is new moon. It's new, the moon is not up. But once the moon starts to become into view during our imaging hours, I want the target at least 61 degrees from the moon before the exposure plan is executed. And then as we get close to full moon, I want it to be 120 degrees. And again, that's this representation here. So working up to full moon, 120 degrees, and then as it starts to wane, I'm willing to have that exposure plan active at a reduced number of degrees as it continues to, its illumination continues to decrease to the point where we get to the new moon again. So let's show, let's go back to this graph here just a little bit more. So let's look at line number 8, or let's go back to this real quickly, and let's just say, okay, 50% on the 8th of moon illumination. So we count. This is 0, 1, 2, 3, 4, 5, 6, 7. So that would be line 7. So we come back over here. 7, need that moon at least 92 degrees away from the target that I want to image before that exposure plan becomes active. Now with my parameters that I'm using, I've got that set at 90. And so now on line 7, 69. It has to be 69 degrees. So my target could be a bit closer with these parameters, and it's okay to image versus 120, where it need to be 92. So again, we could, different combinations, we could go a distance of 60, and then need to be 46 degrees. If I decrease the width to 7, then it can be as close as 27. Again, it's all about how I feel comfortable right now. And again, I'm in exploration mode, so I'll probably change these parameters over time. But the place that I'll be able to do that is by tuning these parameters here, which I can change over time. And now, again, let's go back to 03 for this target. And I only have one exposure plan, and that's the 03. So we go in here, and what I'm saying is, yeah, enable classic avoidance at these parameters, but then I set a relaxation scale, which allows me to set this moon must be down as true. So this exposure plan should not be executed unless the moon is down. And so now let's just take a quick look. Another feature of the scheduler preview is, let's go in and let's see tonight, if it was to run something, tonight is the 5th. We go in here to the 5th, and we say run. And what we see here is it's going to run HA and S2 for 1491, and so that's what it's going to image tonight. Now let's increase this date out a bit. Let's get out to the 10th, and we run, and now it's not going to run anything based upon how I have my moon avoidance parameters set. So if I wanted to image on the 10th, I would need to change something, and so let's go in and quickly do that. Let's go into target management. Let's go into my H plan, and let's change it to 60 and 7, which are the default. Let's save that, and let's go here, edit, 60 and 7, and let's go back to preview, scheduler preview, and let's run it. And you see now, because I've relaxed the parameters, that change that I made said I'm willing to allow that target to be closer to the moon when this plan is executed. So what we can then just go back to this chart here, and what did I set? 60 and 7. And how many, what is the date of that? We're on the 10th. And so if we go to the 10th back over here, and there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that'll be line 9 in our chart. Line 9, I'm saying that that target can now be as close as 36 degrees to the moon, and it's still okay to execute that that plan. But again, I'm going to change this back to 90 and 14. And the way I had originally set, what did I say on 9? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I said it had to be at least, it could be no closer than 77 degrees. So again, how we adjust these parameters in our exposure plans will determine when things can be run. And I'm gonna quickly, while we're on here, I'm just gonna quickly change that back to 90 and 14. Make sure I got the right, and let's do this and edit. Okay, and then we're just going to go back into here, and we're going to hit run. And again, because I've now made a requirement that the target has to be further away from the moon than the previous parameters of 60 and 7, now target schedule will not run anything. Also notice it's not running any RGB stars, it's not running any O3. But let's go to the full moon now, which should be around the 15th. And let's hit run. Okay, 15th, it's not running anything. Oh, yeah, because the moon is up. Okay, the moon is up, exactly. So let's go to the next new moon, which should be the 30th. And let's run. And now you see again, it's going to make a priority for HA and S2. But I want that 03. So let's do this. Let's go back into Target Scheduler. Let's go into my projects here for 03 targets. Let's make this a priority. So we're going to edit that. And let's see if we change the state. And now we go into the new moon and we run, and see now it's going to run the 03, because in the hierarchy my 03 targets have a priority of high. My HAS2 targets have a priority of normal. So hopefully this is helpful to you. I mean, clearly going into an observatory gives me an opportunity to change the way I do everything. I don't have to be in as much of a hurry. I'm going to take advantage of having more available days to image, weather permitting. I'm going to be imaging now when the moon is up, but I'm going to control that of when my HA and S2 exposure plans are executed. I'm going to control that. I'm going to fine-tune that through trial and error, and collecting data with the various parameters being changed here in my image, in my exposure template. I'll fine-tune that over time, see what the results is as I relax my parameters or my requirements, and I'm willing to image closer to the new moon. You know, I'll be able to collect that data and then have some data where the target is farther away from the new moon, and try and see if I can determine a difference in the quality of the data based upon those different distances, which will enable me to fine-tune just how close I can get to the moon and feel comfortable that the quality of the data is going to be within my requirements. So yeah, this is Tom Palmer's target management or target scheduler. And the other thing it's going to do is, if you saw my spreadsheet before, I was trying to track data collection. This is going to tell me how many acquired images, just like as I start to execute these plans in target management. As I start to, let's say, execute this plan, and as I acquire images, it's going to be recorded here how many I've acquired, how many have been accepted based upon the parameters I have set in the image grader. And again, the image grader does not delete the file. It just gives me a pointer that maybe that file I might want to look at further and maybe exclude. There's a lot of advantages to managing a project portfolio, and then it all comes back to this. Instead of building a sophisticated advanced sequence, you could just drop the target scheduler container in to your advanced sequence. You have the triggers that you like, the actions that you like on startup and shutdown, and you have the triggers that you want to have present, like the ones I like: a center after drift, restore guiding. I want an autofocus after a certain increase in HFR or temperature, and then the magic happens with this container, and it has really simplified things for me. I've again been using this for several months, and it's just it's just a great way to image. And now that I'm going to be in an observatory and have more nights available to me, Target Scheduler gives me fine control over when I image, relative to the status of the moon and the targets that I want to image. So anyway, I'm building my target scheduler project portfolio, so I have the right projects in. So when these telescopes hit the observatory, they'll be there. But I mean, once I have remote access, I can continue to build out the project portfolio in Target Scheduler. Okay, this has been a long video, but hopefully it shared some helpful information. If you're not aware of Target Scheduler, it might be something you want to look at. Again, I used it successfully even as a traveler, where I was just out for 3-4 nights. If you have a fixed installation and you're using N.I.N.A, you might want to take a look at this to see what value it might be able to provide you relative to your imaging goals. So again, I've become a big advocate and evangelist for Tom Palmer's Target Scheduler, and if you want to see how it's operating for me under a remote observatory environment, hit that notification bell, subscribe, and you'll be able to be made aware as I continue to develop content around the use of Target Scheduler in a remote observatory environment. Other than that, if you like this content, please give it a thumbs up. As always, check out the links in the video description. An affiliate partner to Amazon. If you use one of the links, go to Amazon and purchase something at no cost to you. I get some credit for that. I have no idea who purchases what. It's totally anonymized, so no worry there. Other than that, thanks for dropping into the channel. See you next time.